Hi guys, it's Urrego here. Um, Today's class is solving systems of linear equations by graphing, and we're gonna have an introduction to linear inequalities. First of all, our vocabulary words, very important. Make sure you take notes on this. No solution is also called an inconsistent system. Inconsistent. One solution is consistent and independent. Infinite many solutions is consistent and dependent. Coordinate plane, order pair, those are terms that we should know also. The terms that I just spoke about is basically this. When a system has no solution, means it's because the lines are parallel lines, and it's called an inconsistent system. When it's one solution, is because the lines intersect at one point. Therefore, it's one solution, and the solution will be the coordinates of that intersection point. And the system is called consistent independent. Now, when the two lines coincide, meaning one is on top of the other one, is the same line, but you have two lines there, then the system has infinitely many solutions. It's also called consistent and dependent. So those are the words that we're talking about right now. Those are the possible solutions of a system of linear equations. Now, when you're graphing, it's easy to see if the system has no solution, one solution, or infinite many solutions because you can see it graphically. But if you're not graphing, and the question is, without graphing, identify if the system has no solution, one solution, or many solutions, or if the system is consistent, independent, consistent, dependent, or inconsistent, then without graphing, then what we have to do is basically rewrite our equations. You see, number one is one system, two equations. Number two is a different system. Number three is a different system. So if we're asked to tell how many solutions or what type of solutions my system has, then I have to rewrite my equations in slope-intercept form. And depending on the slope and the intercept, we can tell the solutions of the system. I just solved for y in the first problem, and if you notice, I have y equals 1/2 of x minus 5/2. And the second equation, I got y equals 1/2 of x minus 5/2, which is the same basic equation. Because the equations are the same, then that means when I graph them, it's going to be one on top of the other one. Therefore, this is a system with many solutions, infinitely many solutions. Now, the second system, I solve for y, and I have my first y equals x minus 3, and the second equation y equals x minus 10. Because these two equations have the same slope, which is 1 on both. Here in front of the x, you should have a 1 and a 1. They have the same slope, they have the different y-intercept. That means these two lines are parallel lines. Because they're parallel lines means they don't touch. Therefore, is no solution. Now, my last equation, when I solve it, I got y equals -2/3x plus 2. And the second one, I got y equals 2x minus 1. Now, you notice slopes here are different. Y-intercepts are different. Therefore, hold on. I made a mistake right here. Is one solution. One solution. So, technically, when we ask to say how many solutions the system has, they don't ask me for the point intersection right now. They're just saying identify the type of solutions. So again, the first system, same equation, exactly the same equation. That means it's going to be the same line. Therefore, the line is going to be one on top of the other one. So many solutions. The second system, same slope, but the y-intercept is different. That means the two lines are parallel lines. Therefore, no solution because they don't touch. The third system, complete different slopes, different slope, and y-intercept. That means these two are going to be intersecting at one point, and it's going to be one solution system. And that's basically for systems of linear equations. Now I'm going to introduce you to linear inequalities, which is simple basically. If you notice, I have y less than 2x minus 1. It's an inequality because you have an equality symbol. Now when we graphing this, okay, when we're graphing this, basically I need to write the equation. I need to graph the equation first. So I'm going to write the equation from here, and then I'm going to draw the line. Now I just rewrite the inequality as an equation, okay? Because I'm gonna graph it using the slope intercept form. Now, when the inequality symbol doesn't have the equal underneath, you see number one, it's only less than. Number two here is greater than, but there's no equal underneath. Look at number three, is less than or equal to. Number four is greater than or equal to. I'm just looking at the inequality symbols. When there's no equal underneath, then my line is going to be the dash line or dotted line. Number two, dash or dotted line. Number three is going to be a solid line because it has an equal underneath. Number four is going to be has an equal underneath. It's going to be a solid line. Now I rewrite my inequality as an equation, and I'm going to graph this. Okay, remember I need a dash line. So I don't know what I'm going to do to make the dash line, but I'll do it right now. My y-intercept is -1, so my first point is at -1. Right here is my first point. Okay, and then my slope is 2 over 1. That means I'm going to go up 1, 2, and then 1 to the right. So that's my second point. Now I need to make a line that goes through those 2 points. And I don't know, there we go. I think I'm going to use this as my dash line and see how it goes. There we go. I think I found my tools over here. So from here and okay, let's try that again. I'm going to have from my y-intercept towards my, there we go, dotted line. Okay, and it's extend the line to the other side. Here we go, and that's the slope. Okay, so dash line because it doesn't have an equal underneath. That's my line. Now, whenever we graph an inequality, we're gonna have half plane. Half plane is gonna be shaded, either the left side or the right side, which this technically is the top of the line, and this is the bottom or underneath. Okay. How do we know? If it's less than, then it's going to be underneath. Or another way to do it is by checking a point on the inequality symbol. So if I check 0, 0, that means my x is going to be 0 and the y is going to be 0. Then I'm going to have, let me write that down. I'm going to have 0, oh my God, is less than 0 minus 1. 0 is less than -1. Now, I'm checking 0, 0 right now. I'm checking 0, 0 is my point, which is here on the left side. Okay, I'm checking that point. And now when I plug it into my inequality, I have 0. I'm going to write underneath is less than -1. Is that right? No, that's false, right? Because 0 is greater than -1. So this side is false. Then the other side has to be true. Therefore, my shade should be underneath my graph, starting from the line all the way underneath. This half plane is the shade, and that's the solution of an inequality. Again, like I said before, if you have an inequality, you say y less than 2x minus 1, because you have y is less than, then it's going to be underneath of your line. Okay, let's try the second one. The second one is a different equation, and I have y, and I'm going to make it as equation equals to 2. Now, if you notice, there's no x here, so this is a special case of a line. Y equals 2, I'm going to go to y, 1, and 2. That's a horizontal line. So y equals 2 is a horizontal line, and it goes through when y equals 2. So let's get to this. So my line, oops. So this is a special case of a line. Let me get a line. Again, there's no equal here, so that means a dotted line, and it's going to go through y equals 2. So right there, you see y1, y equals 2. So it's a horizontal line. Okay. Now I want values that are greater than 2. Y greater than 2. When is y greater than 2? When you got 3, 4, 5, 6. So basically all from the line to the top. All that's greater than 2. Starting with the line. Okay. Now let's go to our third graph. Okay, now I have x is less than or equal to 2. because you have the equal, that means that's going to be a solid line. Okay, now if you notice, if I turn that into an equation, I'm going to have x is equal, horrible x, I'm sorry, x is equal to 2. There's no y's here. That's a no special case. So when this happens, I'm going to go to my x-axis and I'm going to go to 1, 2. Oops. 2, 1 is 2 right here. Okay. So in that moment, that's going to be a vertical line. So x equals a number is going to give you a vertical line. Y equals a number, like on number 2, y equals a number. This is going to give you a horizontal line. Horizontal line. Okay. Y equals a number, horizontal line. X equals a number is going to be a vertical line. Vertical line. Okay. That it goes through 2. So I'm going to get my line over here. And because it has an equal, then it's going to be a solid line. And it's going to go through x equals to 2. So that's my line. Okay. Now, I need something x that is less than 2. Less than 2. So those values, less values than less than 2, that means it's going to be all the left side. Less than 2, 0, 1, -1. So all the shade is going to be on the left side. Okay. The last one. Now we know that when we have a regular equation, I need to write any slope into the form, which is going to be y equals -3x plus 4. And I extended too much. Okay, so kind of a 3, not too good. I'm sorry about that. So I have y equals -3x plus 4. My slope is -3/1. My y-intercept is 4. So I'm going to go here to 4. Y-intercept 1, 2, 3, and 4. Right there is my y-intercept. Let me get this. So 1, 2, 3, 4. That's my y-intercept. Now my slope is -3/1, which is -3 going down. 1, 2, 3, and then 1 to the right. So that's my second point. First point right here, second point right there. And now I have an equal underneath, so it's going to be a solid line. Solid line. So let me start here, and let me get to my second point. Let me get and extend that into the other side. Okay. There we go. So that's my line. Now, I'm saying y is greater. Greater is on top of the line, over the line. So if I say greater, that means all this side is going to be the shade of this inequality. All this side, the top of the line. Okay? If not, you just need to check. I can plug a value also. You can say that, oh, I'm going to check this point, which is 0, 0, on the inequality. Then I'm going to write here 0 is greater than or equal to -3 times 0 is 0 plus 4. So I'm just checking the point 0, 0. That's what I'm doing right now. I'm checking that 0, 0 on the original inequality. I get 0 on the left is greater than 4. Is 0 greater than 4? No. So this side will be false and this side will be true. And that's why we have all this shade on the top. Okay? So that's about it with the linear inequalities. Just an introduction. I'll do systems tomorrow. Have a good one.